Hey everybody. Today we're using R to dig into the Scooby Doo dataset. This set deals with the long-running kids show Scooby Doo and was included as part of the Tidy Tuesday challenge back in July of 2021. If you're not familiar with Tidy Tuesday, I highly recommend a quick Google search on that. Basically, every week you get a new, large, and interesting data set to dig into to practice your tidying skills, your data viz, and your data analysis more generally. One nice thing about Tidy Tuesday is you can access the sets directly using the Tidy Tuesdayer package. I'm going to load up that package, download the set, and then save the Scooby data set as Scooby. While I'm at it, I'm going to load up Tidyverse and set my theme to minimal. I'm not a huge fan of the default gray background for my ggplots. As soon as I've got a new data set to work with, I always want to just try and get oriented in it or oriented with it. So let's take a glimpse at Scooby. That's part of dplyr. All right, lots of variables. We have 75 variables here, 75 columns, 603 observations. And it looks like every observation is going to be an episode of Scooby Doo. I'm not going to want all of these columns. There's a lot of interesting stuff here, like who unmasked the villain, who got to eat the Scooby snack treat. Let's see here, did Batman appear? Lots of interesting stuff if you're a Scooby Doo fan. I'm going to focus in on IMDb ratings and a few of the other variables that might feed into that. So in addition to getting rid of some of these unwanted variables, I'm going to use the select command. I am going to want to fix one problem, and that is that IMDb rating, as well as some of the other things here, IMDb rating is listed as a character vector, and those should actually be numbers. So I'm going to go fix that. So let's take Scooby and let's save a new version as Scooby Small. And I'm going to pipe Scooby into a select command. Now, notice my pipe here is a triangle shape, a vertical bar and a greater than sign. I recently switched to R's native pipe. This is a newer feature in, I think it's version 4.1. So if your R's up to date, you've got this. You don't need to load in extra packages now to use the pipe. Members of the R community seem to be gradually shifting over to that native pipe. I'm on that bandwagon too now. So again, a select command. This is going to choose some of the columns. We can use tidy select syntax here. For instance, just by listing column names. I want series name because I don't think I need index. This just appears to be row numbers. And I'm going to keep everything up to and including format. And then while I'm at it, let's do that mutate so that IMDb is going to be as double of IMDb. All right, we got a warning. NAs were introduced by coercion with that IMDb, with this one. So that means there were some things in that column that could not be turned into numbers in a natural way. That's in red indicating that we should take a look and figure out what's going on there. It's a warning message. It won't break anything. I've already done that. I can tell you just that some of the more recent entries in the database didn't have IMDb ratings or engagements. I think it was the last 15. My guess is just that they weren't available at the time the data set was made. All right, so let's move past that right now. And let's just get a preliminary visualization of IMDb ratings over time. All right, so ggplot with Scooby Small. And for my aesthetics, on the x-axis, I want date aired. And on my y-axis, I want IMDb. And that variable should now be quantitative now, so this should look okay. And to start, let's just leave it like that and get a G on point. So simple scatter plot. And let's go ahead and zoom in on it now. Have that window open to refer to later. Okay, so at a glance, there seems to be a little bit of a downward trend followed by an upward trend later on. We've got a bit of a gap in our Scooby-Doo production here in the late 1990s, it looks like. There's also more spread here towards the end. So a lot of things potentially going on in this data set. If you squint hard, you might also see some clusters, like over here, for instance. That's something that we should take a look at. All right, let's go ahead and add a little bit of color to this. Let's color this. How about according to format? I'm interested in what the format variable is actually doing here. And if I'm going to put in color, I want to make it accessible. So scale color brewer palette equals quote dark 2. Let's see how that looks. Okay, so this color palette certainly isn't perfect, but you can make it out a little better, I think, than the other one. I see this cluster of green dots for segmented TV. I'm going to want to get into that. But what I'm really noticing here is that I'm seeing a lot more dots for TV series than really for anything else. In fact, the only other three formats we have are crossover, movie, and theatrical. So I'm guessing those first three, crossover movie and theatrical movie, have pretty small ends. Let's find out. Let's see here. So let's explore format a little. I'm going to use the table command to just find out how many of each I have. Lots of different ways to do this, of course. So Scooby small dollar format. All right, so 3 theatrical movies, 43 movies, presumably TV movies, and 8 crossover episodes. All right, I think I'm going to want to filter out the movies and the theatrical movies. I think those are sort of apples versus oranges. They're just kind of different than TV episodes. So I'm going to take those out. I'm also wondering about these crossover episodes. So let's try and see what those are. So how about we call a set crossover, and let's just do a filter on Scooby Small. We know we should get 8 rows in this filter. So format is going to be quote crossover. And let's just make sure that that has 8 rows and see what they are. All right, so we did get 8 rows. Series names: Teen Titans, OK Chaos, Supernatural, Harvey Birdman, Johnny Bravo, and then 3 for Dino Mutt Dog Wonder. All right, so I'm already being able to speculate what's going on here. That the studio that makes Scooby Doo, or that had the rights to Scooby Doo, decided to insert one or more of those characters into other shows to try and bring up their ratings. And I actually Googled around a little bit on some of these, like Dino Mutt Dog Wonder. I think this is good practice when you're analyzing a data set. Don't just look at the numbers. Actually ask yourself what's going on. So Dino Mutt Dog Wonder, produced by Hanna-Barbera, creators of Scooby Doo, ran for a year and centered on Blue Falcon and his assistant Dino Mutt, and was later rolled into another show with Scooby Doo. So it looks like what's going on here, and presumably in those other crossover episodes, is what I thought a moment ago, that Scooby Doo is being inserted into another show that isn't really his. So I'm going to go ahead and filter those out too. So let's filter all non-TV series episodes. And when I say non-TV series, I'm going to keep in the TV series and the segmented TV series. The segmented ones is going to be my next question. So I may as well just keep it as Scooby Small, I guess. And let's take Scooby Small. And we'll pipe it into a filter command. And so we want format. There's different ways of doing this. I'm going to do, how about not equal, quote, crossover. Also not equal, to movie. And also, my typing's so terrible, not equal to movie, parenthesis, theatrical. Quick double check. I need a quote or parenthesis inside my quote. I think that's looking okay. All right. So let's see here. 8 and 43 is 51, and 3 is 54. So we should have 54 fewer rows now. And so that's looking good if you look at Scooby Small versus Scooby. So we got rid of what we want. We can also confirm it directly with the table command. Again, lots of different ways. So Scooby Small, dollar format. There we go. All right, so what's going on with this segmented stuff? Let's take a view on this data set and see if we can gather any information on this. One of the things I like about this data set is that it's messy in a very human way. There's just a lot of texture here, a lot going on. And while we could just rush in and start doing statistics on it, that could really lead us astray for lots of reasons. Okay, so TV series and then segmented TV series. So let's go down and find a segmented TV series. There we go. I immediately notice the runtimes, 12 minutes versus 24 here. And if I keep looking at my segmented TV series, maybe I'll do a quick sort here and take a look. There we go. This is a trend. They're all shorter. And if you look up segmented TV series, what you'll find is that basically what's going on here is they've taken a standard TV show, 30 minutes or 60 minutes, and broken it down into little sort of mini episodes that all get aired together. And so, for instance, here, 1978, September 9th, we have these 2 episodes that aired together. And you can see that the date is the same, the engagement's the same, the IMDb rating's the same, the titles are different, however. So if I'm going to do a statistical analysis here, these episodes are going to get double counted. And if I don't take runtime into account at all, they're going to be essentially weighted twice as heavily. So that means this sort of green blotch is going to have some extra weighting. So I want to do a little wrangling on this. So let's combine the segmented episodes for the purposes of considering IMDb ratings. Now, for other purposes, this might not be appropriate. I just don't want them to be counted, these what appear to be single episodes, to be counted twice. All right, so let's call it this thing segmented. And I'm going to start with Scooby Small, pipe it into a filter, because I only want the segmented ones. So format equals quote TV series. I have to watch the capitalization here because it's not consistent. TV series, parenthesis, lowercase segmented. And let's just see if that looks right before I go on. Yes, 175 episodes. That's how it should be. Okay. Let's see here. Then essentially what I'm going to want to do is for every date that one of these aired, I want to group them. I've already checked, but my initial assumption ended up being true, which is that if 2 of the segmented series episodes appeared on the same date, they actually were part of the same show. And so it's meaningful to group them together. So let's do a group by. And I'm going to group by date aired. And then do a summarize. Group by's best friend. And I think the first thing I'm going to want to do is to have IMDb. Just let's do the mean of IMDb just in case some of them did have separate IMDb ratings. All right, I know that that's actually the case, that some of them do have separate. They are always very close together. The vast majority of them have exactly the same IMDb ratings. I'm also going to want to keep a couple other variables. I'm going to want to keep network. I have to somehow deal with the fact that there's going to be multiple entries for each date, there's going to be multiple entries of the same network. I'm going to get around that by doing unique network. They all appeared on ABC. This ends up not mattering. I want to keep the series name, same thing as before. And the last thing I want to have in here is total runtime. So what I want to do is I want to take the sum of the runtimes that I have. All right, and then let's take a look at that and see if I got what I wanted. All right, date aired, IMDb rating. Maybe I should round that. Maybe I'll get to that later. Network and series name. Is that all the variables I want? Checking my notes. I think that's all I want. All right, now I'm going to want to put that back together with my, oh, and there's total runtime too. Sorry. I'm going to want to put this back together with the other elements of my data set. So how about non-segmented? And this is just going to be a straight filter. There's actually lots of ways I could do this. I could do this with a filtering join if I wanted, but I think I'll just do a filter. So let's filter it with format. You know what I'll do? I'm just going to copy and paste. Not equal to segmented TV series. And let's see here. I need to make sure that, because I want to recombine this with the segmented data set, I need to make sure that my columns match up. So I need IMDb. Ooh, I need date aired first. I'm going to do an R bind in a little bit. And if the column names don't match up, it's not going to work. Network, series name, and total runtime. Again, the column names have to match up. So my total runtime is just going to be runtime. So here I'm using select to rename a column as I select it. All right, and if I did this right, I should be able to take Scooby, let's call it Scooby tidied, by doing an R bind of non-seg underscore not plus and segmented. Cross your fingers. There we go. All right. Let's take a look at that. All right. So it's looking pretty good. We've got 449 entries with the variables that I said I wanted. Date aired, IMDb, network, series name, and total runtime. I don't specifically care about total runtime, or I won't care about it for the rest of this vid, but it indicates at least that I've dealt with the segmented issue. Okay. A new ggplot. Same variables, essentially. I'm not going to be interested in format anymore. I've got that all taken care of. But let's take Scooby tidied. And again, put date aired on the x-axis. IMDb on the y. And I think this time I want to color it by network. And geom point. Fix that spacing or it will bother me. And let's do scale color brewer. Palette equals quote dark 2. All right, great. So by taking out those movies, we're seeing a lot more separation between our groups because these are separate TV shows that are distinct from one another. The movies are all kind of standalone to one degree or another. Whether or not I had the coloring in here, it would be immediately apparent that something's going on right here. And the coloring lets me know that this is a show that was run on the CW. That just was not popular, around 2008, something like that. Let's take a look at what that is. So let's call that CW. I'll do a filter. I guess I should do a pipe first. And I want to do network equals, quote, the CW. And let's view that. All right. So, as we know, the IMDb ratings are low and the network is the CW. The series names Shaggy and Scooby Doo get a clue. So, I looked that up. And we can read a little bit about this abomination of a show, or at least it's considered to be that. I've never actually seen it except little bits of clips that I saw on YouTube when I was researching this video. Suffice it to say, the animation style is very different. Many members of the Scooby-Doo gang are not present on a consistent basis. Even the mystery-solving premise was twisted pretty far. So this strayed pretty far from Scooby-Doo's very successful formula. Okay, so based on this visualization, it sure looks like there's that the network that a show ran on is giving us important information about the popularity of the show, or at least the IMDb ratings of the show. And in particular, that episodes that aired on the CW did worse. So let's test that. Does network inform IMDb? Is the CW really so bad? And what I mean by is it really so bad is just that is this difference statistically significant, or could this just be bad luck? Maybe just for whatever reason, even though the episodes they were making were just as good as all the other episodes, they just happened to just by chance receive worse ratings. I'm talking about an ANOVA here. So let's do that. An ANOVA is just a linear model. I'm going to save it as model. AOV is the ANOVA command I'll use. Again, in R, there's different ways of doing this. The response variable is IMDb. The explanatory variable is going to be network, not date aired. Don't want to do an ANOVA with dates. And the data set is going to be Scooby tidied. And then we can get our ANOVA table with the summary command. There it is. Okay. The p-value, infinitesimal, highly statistically significant, not a surprise at all that knowing something about what network show produced the episode gives you some information about the IMDb ratings. You can just visually see it that's going to be very convincing. Now, we don't want to jump to conclusions that this means the CW is worse. Remember, ANOVA is an omnibus test. That just tells us that there's a relationship between these variables, IMDb and network. It doesn't tell us specifically which category of the network variable is making the difference. To say anything about that, we have to run some sort of post hoc test. There's different choices for that. I'm going to use the Tukey on a standard differences. There it is. And I can just plug in the model into that. This is going to do pairwise comparisons between the groups. You can think of it as like almost like t-tests compared to sample t-tests. But it's going to control the overall error rate so that the overall error rate will be 5%, even though it's doing multiple comparisons. There's a lot of different groups here, so it's going to give us a big table. Can I make this look any better? Let's see. Yeah, that's okay. All right, so I'm interested in the CW, although you could potentially be interested in other comparisons. So for instance, the CW versus ABC has a p-value of, well, all zeros. You also get a confidence interval as well as the actual difference between the sample means there. So very safe bet that there's an actual difference between the CW and ABC. Similarly versus Boomerang, similarly versus Cartoon Network and the other networks. Okay, so yep, the CW was bad. Maybe I shouldn't say the CW was bad. Maybe I should say Shaggy and Scrappy Doo Get a Clue was considered to be bad. Let's see here. So the last thing I want to do, let's get I'm going to go ahead and go out on a limb and say an awesome bar chart. for average IMDb ratings for the various networks. Okay, so let's see here. I'm starting with Scooby tidied. I am going to want to get average IMDb ratings for each of the networks first, and then I'm going to want to make a bar chart where the heights of those bars for each of the networks is going to be specifically that mean IMDb rating. So let's do a group by. Let's group by network. And then a summarize. I'm using American spelling today with the summarize with a Z. How about mean IMDb is going to be the mean of IMDb. And I'm pretty sure I have to do an NA.RM because we had some NAs introduced by coercion into our IMDbs. Way back up here when I did my as double command. Okay, so that's going to be true. All right, and you can take a look at that. There it is. But instead of just seeing that table, I'm going to pipe that into a ggplot. So that data set is going to be my first argument, so I need to just start in with the aesthetics. My x-axis is going to be the network, that categorical variable. The y-axis is going to be the mean IMDb. I also am going to add color to be IMDb. So I have the same aesthetic graphed twice. And it's a geom call. Even though it's a bar chart, here I'm specifying both an x and a y aesthetic, so it's a geom call. Let's just see how that looks. IMDb not found. Okay. Color equals mean IMDb. There it is. Ooh, it's on a scale here. Color is not mean IMDb. Color is network. And of course, I want fill. Nice thing about R is that you can produce lots of plots fast and make little changes as you go. Let's add the scale fill brewer to make this a better color palette. All right, so lots of things on my to-do list here. I'm going to want to get rid of that legend. These labels are overlapping, potentially badly depending on the scale here. I'm going to deal with that somehow. I'm going to fix my labels. And the other thing I want to do is I want to put the actual number, the mean IMDb rating, on top of the bar. Finally, I want to reorder these bars so that they go from tallest to smallest. In fact, let me maybe do that first. So that is changing my x value. I'm going to do a factor reorder on that. Factor reorder takes the factor variable and reorders it according to some quantitative variable. So in this case, mean IMDb. And that should put them in order. All right, so that's nice. I want them going from tallest to shortest, so maybe I'll do a negative sign on the mean IMDb. There we go. This thing is going to bother me, this legend off to the side. I'm going to fix that right now. So how about this is, since it's a non-data aspect of my plot, it's a theme element. It's legend.position equals quote none. That's a little bit better. The networks are overlapping. As long as I'm dealing with theme elements, let's deal with that. So I think I'm just going to rotate those labels a little bit. So axis text x equals element text, element, I think it's underscore, and angle, I don't know, how about 15 degrees? All right, that's looking nicer. Let's put some labels on here. And then I'll do the more interesting part, putting the numbers on top. So my X label is going to be network. This has to be in quotes. My Y label should be mean IMDb rating. And how about a title? Scooby Dooby Doo. Oh, and a plus so that I can actually have that network out of there, the legend out of there. All right, not looking too bad. Let's put some numbers on top of here. All right, so I'm adding another geome. This is going to be, I'm going to do it with geome text. And the geome text still takes your X and Y aesthetics, but it also needs a text aesthetic. Just basically to let it know which character vectors to plot in those X and Y positions. So the aesthetic here is label, and the label is going to be mean IMDb. Oh, and I need my plus here still. All right, so 2 issues, right? Too many digits, and you can see that the Y coordinate is exactly the Y coordinate that I specified before. I'd actually like to make this a little higher or possibly a little lower. So first things first, let's deal with this rounding. So for the mean IMDb, what I really want to do is round that to just 1 decimal place. So that looks a little better. And then the other thing that I can do with my geome text is to do a nudge. Or one other thing I can do here is to do a nudge. And there's a little bit of guess and check here for me, or trial and error. I want to nudge it up by, I actually did this beforehand, so I know I want to nudge it up by 0.4. All right, well, maybe just a tiny bit less than that for the big one. Let's try 0.3. That looks okay. Obviously, lots of other things I could do with this to make it look even better or convey more information. All right, that's it for my analysis of the Scooby Doo dataset. Hope you had fun. Hope it gave you some more ideas of things to do as you explore this set.